All right, and now moving up to the last keynote of this day, I have to welcome on stage the next speaker. It's gonna be very easy because it's gonna be me. So it's gonna be a very short introduction. Yes, so my name is Mathieu Bailey. I'm the director of CYSAT. I have had the pleasure to be overseeing this event for the last 4 years, since the first edition in 2021. Margot will be my MC for this keynote. There was a free slot on the program, so I said, why not take my chance this year, because I have an important message to convey to the community. So this is this year, and also the first time I wear a tie at CYSAT. So it's 2 firsts for this year. All right, this keynote is entitled Towards a Space Internet Security Standard. We talked a lot about standards today. We see more and more than connectivity via space assets. So I call it the space internet. And the question is, how do we standardize security for the next years and decades to come? Right, let's start with a quick definition of the space internet. It's just a way to say that we have devices that rely on space assets for communications. So here's an example of a visual I took to mention all the different devices on ground, on the sea, in the air, relying on satellite communications. This is on Earth. And we also have this vision of having a space internet in space. This is a visual I took from NASA. Really interconnecting planets between themselves. So the space internet is happening today, as the picture on the left shows, and it's going to happen also in the future. And this is a very, let's say, they all share common characteristics, such as a growing volume in terms of the amount of data that is being communicated, a growing number of nodes connected, number of users relying on this technology. It's getting also more and more complex with the different devices, protocols, synchronization times, really becoming a system of systems. And more users that depend on these services via space assets, so more and more critical. So we need more protection. That's the space internet. And growing volume, growing complexity, growing in criticalness, we've seen that many times in the past with different types of internet. We've seen that with the terrestrial internet, the internet that we all know today, that we use with our personal computers, started from the 60s. We also know that from the cellular internet, smartphones, mobile phones, all connected to each other. We've seen that also with the wireless internet, connecting our homes to the terrestrial internet. We've seen that also with the things, the Internet of Things, the IoT, and now the next step is the space internet. And what is interesting is that all these different types of internet went through very similar challenges, and the common response to ensure a proper protection was standardization. And this is really the topic of my talk today, is to look at what happened in the past, how did they get to the way it is today with these different types of internet. So I'll go quickly through these examples, but this is the terrestrial internet, born in 1969 as a research project in the lab in California. And then quickly, security research came and first communication standards. So the goal was to standardize the communication protocol to be able to grow the network and to have more users. And after that, quickly security researchers went into the place. We had the first virus worm in 1988, showing that this network, these communication protocols are actually vulnerable to cyber attacks. And then the response is usually by reactive measures. So saying, okay, this researcher in the lab showed us that this particular protocol was vulnerable to this type of attack. So let's build one countermeasure that protects us against this very specific type of attack. This is a very reactive way of working, but it has worked in the past. There was HTTPS, for example, in 1994. But then it happens again and again. So security researchers are very stubborn. So if you come up with the countermeasure, they come up with the new attack and so on and so on. And the way usually it ends up is that communication standards become to have integrated security by design into the main communication standard, and this evolving with time. So this is what we have today with the current internet. Different types of VPNs, TLS security, IPsec security, and so on, that allows us to share critical information via this network. And same thing with the cellular internet 30 years ago. Started small scale with the GSMs that was standardized, and then the communication standards that came with the body called 3GPP in 1998, and then security guys that comes in showing vulnerabilities, hacking the systems, comes in reactive measures with LGE, and then later on more security research, and then eventually came up with the security by design standard into the 5G in 2018. Same story with the wireless internet 20 years ago. Started small scale, communication standard with the IEEE, then adoption of the technology, millions of users of Wi-Fi and wireless internet. A lot of vulnerabilities disclosed, many ways to attack wireless systems, and eventually security becoming integrated within the main communication standard, in this case IEEE 802.11. And the last example, IoT, I mentioned it, same story, started small scale in the lab more recently, 2009 for LoRa. Communication standard in 2015, security research a bit later on with hackers, ethical hackers showing how they could hack connected objects. And then LoRa comes up with the security by design standard showing how you should be able to do the key exchange, the protocol, the encryption, and so on and so on. So this is a very common process to all these different types of internet: small scale, mass adoption, communication standards, security research, cyber attacks, security standards, which is often in the first place a standalone document. So there is a main communication standard and then a security standard, not really related to each other. And then eventually, after the many painful experiences, they all blend together to form a security by design that blends communications and security. And we've seen this in these many types of internets, a lot of advantages to have a security by design standard, especially in terms of interoperability, to make sure that all these devices can communicate with each other, and also with security. This is the most important. So that enables growth of the network, because you can build trust with the users, which is absolutely fundamental in growing the technology. And that also brings new use cases, for example, maybe governmental customers that want to use the technology because it is now secure. A few inconvenience cons for making security standards. The first is that it takes time. Obviously, it takes a bit of money. Then you need to have some governments, some standardization organization, and that gets political. We see it with the terrestrial internet. People arguing that this is too much American. Who really owns and controls the internet? So it gets political. And also the way you can control these standards is also problematic, because you can have nice standards on papers, but then if nobody is actually implementing them, it's absolutely useless. But nonetheless, the advantages are much heavier than the inconvenience. So the question now is, where do we stand for the space internet? Well, the bottom line is that we're not there yet. So we do have small scale, obviously, since 1957 and Sputnik. We're now currently through adoption of the technology. We expect thousands and thousands of satellites in orbit. We have actually currently probably something like 7,000 satellites, which is huge. We have communication standard to communicate with satellites. We've had some security research and cyber attacks. CYSAT is one example, although the satellite actually was not properly hacked. But security research exists in the space industry, and CYSAT actually as an event is a good example. But the question is, what's next? So in terms of security standard and security by design standard, this is exactly the point I wanted to address today, is to look at what do we have currently in the landscape that could serve as a security standard and a security by design standard to protect the space internet. And also, if you get there to step number 6, when you really, if you do have a standard that includes the communication protocol and also the security, it's not even the end of the story, because eventually you might need to have some legislation, some regulations that are pointing out to this standard to legally force satellite operators to implement the standards you are enforcing. So having a law, having some implementation on the field, which will raise a lot of technical questions about what exactly you need to do. And then when you have figured this out, which is not obvious, then you need to be able to control how this has been enforced. So it's a long way. And then the bad news that you have to do it all over again, with security. Security is a moving target, so to say. So these standards need to be updated, the countermeasures need to be updated, the control need to be updated. So it's a loop that is basically never ending. And for the space again, so the message is that time is running. So we're now going through the exponential growth of the industry, of the number of assets in orbit. In blue, you have the number of actual satellites launched. And in red, you have the forecast by Euroconsult. And they're claiming that we'll achieve 29,000 satellites in 2032. So it's really now the time that the industry as a whole could point out to some security by design standards to be able to show the lawmakers that this should be the ones that should be enforced. So the questions was, what do we have in the landscape off the shelf in terms of communication standards and security standards for space? So this is kind of the list that is very personal. I showed this list to my team. They were not very happy, but I'm still showing it today. So it's a bit comparing apples to pears. So I apologize if it's not exactly what you expect, but that's my own list. So starting with all the proprietary protocol. So in the space, we like, especially at the beginning, we like security by obscurity, really defining specific proprietary communication protocol with the same specific security measures. And by definition, a proprietary technology cannot become a standard. So this is obviously a no-no. New space, CubeSat companies on the other hand of the spectrum, they like to use CSP, which stands for CubeSat Space Protocol, which is very used for CubeSat missions. This is not a standard per se. This is more an implementation that you can find. It defines how you can talk to a CubeSat. It does also some recommendations about security, but it's not a standard that could be applicable to all missions. And then we're getting into the more serious organizations. So IEEE, I mentioned IEEE, which is a huge organization and that was known for their standards for wireless internet, as I showed before. And surprisingly, I don't know, I did my own research. Maybe I was too quick, but I couldn't find one standard of IEEE that explained and defined how you should communicate with a satellite. I just didn't find it. Maybe there is one. If you know, please point it out to me. But I could not find it. So there are lots of IEEE standards, but none about satellite communications in my best knowledge. And interestingly, IEEE is working on the standard for cybersecurity for space systems. We have some people here in the innovation corner that are representing this working group of IEEE working on the security of space systems. And this standard is expected to be released in 2025. So that's interesting, but it sounds like a bit incomplete in my personal opinion. Then we have the ECSS, which is extremely popular with institutional missions. There is a standard for the communication, telemetry, telecommand. And there is also work in progress because ESA is working on a new ECSS, which is a distribution of the quality insurance. It's called Space Product Assurance, Securing Space Systems Life Cycles. That is also expected to be released sometime in 2025. It's also serious work. And then last but not least, there is the CCSDS that you may have heard about, that has some standards about communications and also standards about security. And this is the standards I would like to detail a bit today, SDLS in particular. So what is CCSDS? It stands for the Consultative Committee for Space Data Systems. To me, it sounds like the most legitimate organization in the industry in the sense that they've been around since 1982. They are made of 27 countries, so really representing a large part of space nations. They've been working on standardization communications at all layers of the protocol and really related to the ISO communication stack, so easy even for non-space engineers to understand. They cover now all end-to-end data and communication architecture. And most importantly, CCSDS standards have been used for more than 1,000 space missions. And you can see a bit some examples of the agencies that are contributing to CCSDS standards. And these guys have been, so CCSDS is about 200 experts working on these communication standards. And the good news is that they've been working on space security since 2008. So it's a working group that is about 20 people, to give you an idea. And they published about 15 books with different colors representing different things. So the green ones, for example, are for information only. The pink ones are recommendations, draft, and the blue ones are actual standards that you can implement and use that have been tested by all these agencies. And this is a bit of a big picture of what CCSDS security looks like. So I mentioned they've been working throughout all the layers of the ISO stack, starting for the level 1, the physical layer, all the way to the application layer, and they have defined some security strategy for layer 2, layer 1, 2, 3, 4, and 7. So a very complete, extensive view of security for satellite communications. Layer 1 is bulk encryption and transec. It's mostly for the military, so that's frequency hopping, that kind of stuff. So it's more popular with defense missions. So I'm going to discard it because I'm mostly focusing on civil applications. And the interesting one that I would like to highlight today is the Space Data Link Security Protocol at the level 2. Also called SDLS, which has the advantage to be at the lowest layer, just right after the physical layer, which has some interesting advantages. And especially these two books, SDLS, Space Data Link Security Protocol, and SDLS, Extended Procedures. So two publications, two documents. The first one was released in 2015, and then they've updated these two, 2022 and 2020. And the goal is that these standards can help satellite operators to protect their satellites against the most obvious cyber attacks. So typically eavesdropping, tampering, impersonation, and replay attacks. So really protecting the confidentiality, the integrity, and the authenticity of the data, and especially the telemetry and telecommand. So it's pretty complete in terms of security perimeter, let's say. And again, the advantages to work at layer 2 is that it is packet agnostic, so you can do pretty much whatever you want above layer 2, so you can use it for IP packets and so on and so on. And working at the low level also ensures low energy consumption, which is absolutely critical for space applications. SDLS shows you how to protect satellite communications with the full end-to-end security. So it can be embedded on ground within the mission control software and mission control center, and also on board the spacecraft. So embedded within the flight software to make sure that the telecommunications are protected end-to-end. And this can be applied to TMTC links to really operate the spacecraft, but also for the payload data link when you want to download, for example, any types of data that are coming from the sensors on board the spacecraft. And the standards define these two types, ground and space, but also with some flexibility that can adapt to particular missions and particular implementations. These two documents actually define procedures, so-called procedures. The core procedures in the SDLS standards are called apply and process security. There are only two procedures, very simple. That basically define how you can encrypt and authenticate a data link. Could be TMTC or payload again. And this is, to me, authenticated encryption, the absolute bare minimum to which any satellite operator should be able to do. And today, as far as I know, any company can launch a satellite without any protection of its data link. At least in Europe, it's going to change in France soon with the new French space law. But at least it's been the case for the previous decades. So this should clearly be a must-have requirements. The procedures defined in the second standard are a bit more advanced in the sense that they can provide a lot more flexibility to the mission and the ability to respond to some events. For example, by renewing the keys with OTAR abilities, key management functions, configurations that you can choose, monitoring functions, etc., which are very interesting, especially when you start operating constellations, for example, where it is difficult to accept to have only symmetric key hard-coded in your system. So very complete, a lot of advantages to use CCSDS SDLS. Again, experts, they've been working on this for about 15 years. It has flown in its flight heritage. It can secure TMTC as well as payload. It is end-to-end. You can work with any types of packets you want above layer 2. There is some flexibility that is left in the implementation. It can cover the needs of basically any space missions. So I see a lot of advantages to use CCSDS SDLS. Maybe a few inconvenience. The first one is that it still remains confidential among space engineers. When we talk to satellite operators, a lot of them know CCSDS, but very few of them know SDLS, which is too bad because that's the security implementation of CCSDS. So that's why also we're trying at CYSAT to make it more visible to all the community. It's also difficult to implement as a commercial company because there is no commercial implementation available yet. We're working on it at CYSEC. And also, CCSDS has got a little bit of an old space reputation. I don't know if there are some CCSDS people in the room, but it's true that when we talk to new space companies, CubeSat, SmallSat, they look at CCSDS and as institutional standard. It's actually not true. You can use SDLS with also new space missions. All right, so if we recap a bit, what could be the story if we try to focus on CCSDS, SDLS standards for the space internet? Well, it could be very similar to the other types of internet, starting with the small-scale research projects. We have Sputnik in 1957, communication standards defined in 1982 by the CCSDS committee. With security research, actually I was told this morning that it dates back from the 90s. There were some ethical hackers that started playing with CCSDS standards and showed the CCSDS committee that they were able potentially to really hack a satellite. That was in the late 90s, and that's why they created this working group about security. That eventually led to the first standard CCSDS security standards, not dedicated to SDLS yet, adoption of the technology, and then eventually SDLS is now fully blended with the CCSDS standard. So that's exactly what we're looking for, a security standard that is fully embedded with the main communication standard. So in conclusion, again, I showed you that we've seen this process many times with the different internets, and the bottom line was to have security by design standards. In my personal opinion, it is absolutely unavoidable that we eventually get there in the space industry. The question is how and what do we want to impose? And in my opinion, CCSDS security standards, they appear today to be the most open, complete, legitimate work. So it exists and we should use it. So in my opinion, the CSDS security standard, they should serve as the foundation to all current and future space laws. We don't need to reinvent the wheel if we have already all this work that is available. Thank you so much. I'll leave you with this saying. Do you know? It's mostly from the French Alps. It's called in tartiflette. Tartiflette is a very heavy dish with a lot of cheese.
Not really representative of French cuisine.
Exactly. So that's kind of a funny saying. In tartiflette we trust. And obviously my saying would be in CCSDS we trust. Thank you so much for listening.
Thank you, Mathieu. Well, I would love to know if there are any questions from the audience, but please don't sit on the, no, not on my seat, but on the iPad, because therefore we will never know if there are questions from the audience. But of course you can sit. Actually, there are questions from the audience. I have two, but let's start with that of the audience. One from Jackie, also known as Juri Rong Cheng. When implementing the standards, how are security and availability balanced? Are there any differences compared to terrestrial?
That's a good question. Yes, obviously satellite communications are a little bit different than terrestrial communications. A satellite is not 100% of the time available. So in low Earth orbit, for example, you can only access it twice a day, maybe 3 times a day for a couple of minutes. So that changes a lot the way you work. So that's why we need security standards that are specific to satellite communications. And again, that's why CCSDS standards are very interesting to me. I don't know if that's full answer to the question, but that's my best.
Well, that's your answer at least. We have a few minutes left. Do not hesitate to raise question. You just mentioned earlier that you were working on a commercial application of the SDLS. So you intend to be a standard setter yourself.
Yeah, so we've been working on the commercial implementation at CYSEC. And we've done the first demonstration last year at CYSAT for the ground part, and now we've been working on the space part, testing on UpSat, the ESA CubeSat at the end of last year, and now rolling out the commercial product. So yes, it's the first that we know of, so we hope it will be successful on the market, also depending on how much interest there is for CCSDS SDLS.
Mm-hmm. Another... Another question from Winter Love. Thank you for your nice presentation. This is first a remark. Regarding the confidentiality of SDLS, I think there is a common trend that space is getting too complex to be told in a single major, for instance, in space engineers, for 2 space engineers. How should we cross-pollinate 2 space engineers?
Education, yeah, that's a big topic. To me, that's one of the major obstacles to make security more visible and more known in the industry. I often mention the anecdote that we hired a young engineer that graduated from Supero, and during his bachelor, he had only a few hours of security, and this course, security course, was the only one that was cancelled during his bachelor for whatever reasons. So he ended up graduating without any security background. So we need to do better. We see it a bit at the different engineering schools. We're trying also to invite students at CYSAT for free. They can come and check out the events, and also make themselves more visible, because a lot of these companies are looking for engineers, maybe training them, but also the schools need to do their part. So it's the job of everybody. Yeah.
Raising a community is crucial, as you mentioned also during your presentation. I think there was a question from the audience, but someone who did not post it on Connects Me. Am I right?
It's all right. I think it's time for the cocktail. So
yeah,
I'm getting thirsty.
We are about to end our first day. Earlier on, you said that tools must be proactive by design, and I think that really applies to CYSEC too, because within the first years of its foundation, you've tried yourself to build a community with launching this CYSAT event that is now at its 4th edition. And I think, well, it's maybe too early to say, but we've had nice exchanges today.
Thank you. Yeah, and we still have one more day tomorrow. Just to give you a bit of a teaser for the master stage here, so please come back tomorrow. We have some industrial keynotes tomorrow. We have CGI, DISC, GMV, Nexat, Microchip, that will take the microphone tomorrow to present what they've been up to in terms of security. I will be moderating a panel with new space companies and especially their heads of security to ask them if this is their dream job or absolute nightmare. And we'll also have Highway Square that will be back to the program with Nicolas Guillermin from DG Defis, and Florent Rizzo from Cyber in Flight with a keynote on the space security business.
Indeed.
And the way we share information with the different CYSACs. That's the program of tomorrow.
What a nice program indeed. But first, a networking cocktail. Thank you very much for your attention and attendance. We're looking forward to keep on talking to you.
Thank you. Have a good evening.